All right, this particular problem, the table below shows the height h in feet and the number of stories n in some notable buildings. Question A is asking which variable h or n is independent variable and which is dependent. Here, height is dependent on the number of stories. So that's the reason n is your independent variable and h is your dependent variable. Part B, plot these points carefully. On a sheet of graph paper and draw the line that seems to best fit the data points. Let's see here. All right, the highest is 110. I'll start from 0 and I'm gonna go um, like this should be like in the middle 10, 20, 40, 60, 80, 100 and 120. And I will go on the y-axis, 200, 400, 600, 800, and 1000, 1200, and 1400, so forth. So first one is when, and this is my h and number of stories and the height. N is 102, somewhere here, and height is 1250, somewhere here. Let's say this is just estimated points. When N is 61, 788, somewhere here, and N is 110, and in the middle, let's assume 1450 goes all the way here. And then when N is 72, 70, 72, 921, maybe somewhere here. And when it's 40, 546, 5 somewhere here. And 31, 374, and 45, 620, 500, 600, maybe somewhere here. All right, this is the approximated scattered diagram. And then it says here, draw the line that seems to best fit the data points. At this point, it's your estimation. Let's say I want, looks like it's somewhere here, maybe, something like that. Estimation, just an estimation. So this is the answer for part B. C, estimate the equation of the line. If you use your graphing calculator, you'll get the best fit. But at this point, I'm just going to estimate using the points. Usually it's given, which points to be used, or you can pick pretty much the like 2 points that looks the best fit for you. So looks like 80 and 1000. Did I miss that? Problem. Uh, Instead of these, I'm just gonna erase this and let's pick 2 points that looks the best to your eye. Probably it is this one, and let's say this one I'm gonna use first and the last, obviously. So then I'm gonna use the points 31, 374, And then the last one, 110, 1450. I'm going to first calculate the slope. That will be the change in y, 1450 minus 374 over 110 to 31. So 1450 minus 374 and divide this by 110 minus 31, which is 79. Oops. And let's say it's approximately 13.6 over 1. Alright, so then I'm going to use this point. Y minus y sub 0 is 374. Slope x minus 31. So y here is equal to 13.6x minus these two multiplied. 13.6 times 31 is 421.6. And then by adding 374 to both sides, I'm going to add that in here. So y is equal to 13.6x minus 421.6 minus 374. 47.6 is the estimated best fit line to your eye. All right, so I did the C, and then what's happening of the slope of the line? Slope is 36.6 over 1. This is the change in height, y, to change in x to n. So then you can say that the for part C, you estimate the slope to be 13.6, which tells you that the height of the building, increases. Is a positive slope, 13.6 feet approximately for each story. For each story added to the building. All right, so this is my answer for D. And now E. Use your answer to part C to estimate the number of stories in a building 860 feet tall. So 860 is your height. So using y is your height. So 860 is given. 13.6x minus 47.6. I'm going to add first of all 47.6. And the answer for that is plus 47.6 is 907.6 is 13.6x. Then I need to divide both sides by 13.6. So then x approximately, which is your n actually, 907.6 divided by 13.6. So x approximately 67 stories. Your x is here is n, so it's approximately 67 stories. For F, what is your best estimate of the height of the building that has 96 stories? So that will be y 13.6 times 96 minus 47.6. So the number of stories given, x is your n. So 13.6, let me see, multiplied by 96 minus 47.6. So 1,258 feet is your estimated height. Hope this helps. I'll see you next video. Thank you.